All right, we're in chapter 6, 3. So these sections have been different leading up to this point. From now on, we're going to talk about all radical functions. Um, why are we talking about radical functions with the first two sections being inverse functions and composition of functions? Because the inverse of a function is to undo the function. Well, square roots are inverses. If you square a function, unsquaring it would be square rooting. So this is why it falls into that category. So when we talk about square root functions, it says if a function contains a square root of a variable, it is called a square root function. It says the square root function is a type of radical function. So when they say a radical function, this is a radical symbol. A square root is that radical symbol. Technically, there's a 2 here. Do we write that 2? No, it's kind of like 1x. You don't really write the 1. We don't write the 2, okay? But radical functions have square roots, cube roots, fourth roots, and so on and so forth. So that's why it's a radical function, because it has a radical. This little part here is called the index, and that number indicates what type of root it is, okay? So when we talk about just simply square root functions, we're just talking about if that index were 2. So let's talk more about that. We have been used to having polynomial functions where our domain is all real numbers. If I put any number into my function, it usually will give me a result. With square roots, though, you can't do that. So think about that logically. If I had the square root of 25, if I put a positive number in there, 25, I end up with 5. I get a result. If I put 0 in there, which is neither positive nor negative, do I get a result? Yeah, I get 0. And if I put square root of negative 25 in, so I put a negative in, I don't get a result. So usually I test with positive numbers, negative numbers, and 0. So we know with square roots, I just can't have negative numbers in there. So if you can't have negative numbers in there, you can only have 0 and greater. You say your domains x is greater than or equal to 0. That also means that negative values aren't coming out, because think about it, square roots are just the positive numbers or 0. So graphically, it would look like this. If I put in 0, I get 0. If I put in 1, the square root of 1 is 1. If I put in the square root of 2, I don't like that. Let's try 4. I get 2. So it's going to have this slow curve. Okay. Intercepts, well, we see we actually cross at 0, 0. So our x-intercept and our y-intercept is the same value. It is not defined, meaning it doesn't work whenever we have negatives in here. So if x is less than 0, it doesn't work. And our end behavior, as x approaches infinity, f of x is approaching positive infinity. It's going slowly curving up. Okay, it's not going down, it's slowly curving up. We don't really have anything over here because it's not defined. So we just say as x approaches infinity, f of x approaches positive infinity as well. Okay, so identifying domain and range. So we said that this stuff underneath the radical can't be negative. Well, this stuff underneath the radical is also called the radicand. So the radicand cannot be negative. So the radicand has to be greater than or equal to 0. Just like we had mentioned up here, x has to be greater than or equal to 0. So if all this stuff has to be greater than or equal to 0, then what does x have to be in order for that to be true? So you take your radicand, you set it greater than or equal to 0, And so your domain, as long as x has the value of -4 and greater, then your function will exist. Now, why can it be -4? Because -4 plus 4 is 0, and that's okay. You just can't have an overall result of -4, but x can be -4. The fun part of this is to find the range, you simply just plug in the domain and that pops the range. So if I substitute a -4, I get 0. So y has to be greater or equal to 0. Okay, over here, same thing. I want you to try this on your own and then play the video back. Okay. The radicand has to be greater than or equal to 0. Therefore, your domain is greater than or equal to -6 because it'll make it 0. Okay. Well, when I substitute -6 back in, what happens? -6 plus 6 is 0. The square root of 0 is 0, plus 0 is 2. And if you're like, what? Well, go off to the side and try it. -6 plus 6 plus 2. The square root of 0 plus 2. 0 plus 2, 2. Okay. Now you try. Try again at the bottom. Pause. Try it yourself. Okay. It's a little out of focus. So as you can see, when I'm filming these, I go back and forth between this DocuCam and my iPhone. And they both have pluses and minuses. The DocuCam, though, tends to record a little dark, and the iPhone records a lot brighter, but it's more shaky, even when I use the stand. So I have to keep trying things. Okay. This next video, it says to graph the square root functions. Well, we're going to graph these functions by using our domain and ranges. Normally, when we graph a function, we just try random numbers. We have done 0, 1, 2, 3, and -1, -2, -3 when we are desperate. As we've gone through the chapter, we found better methods. So let's talk about this. When we have linear equations, y equals mx plus b. Okay. We have begin with b and we've moved with m. We didn't use a table of values. When we had quadratics, okay, what did we do? We graphed using the vertex. So we put this in vertex form and graphed using the vertex. When we had polynomials, we just kind of used tables of values with numbers on either side. But here, we're just going to start using the domain. So let's look at the radicand. X minus 2 needs to be greater than or equal to 2 or 0. Therefore, x needs to be greater than or equal to 2. So that means x has to start at 2. I could not use negative, positive, and 0. I mean, you could, but I think you're wasting your time. So start with 2. When you substitute 2 in, you're going to get 0. 0 plus 5 is 5. Okay, let's substitute 3 in. When I substitute 3 in, I'm going to get 3 minus 2, which is 1. Square root of 1 is 1. 1 plus 5 is 6. This focus is not the best. Okay. Well, let's put in 4. If I put in 4, 4 minus 2 is 2. The square root of 2 is not pretty, so I'm just not going to use 4. If I put in 5 into here, I get the square root of 3. I don't like that. If I put 6 in, I get the square root of 4. So 6 minus 2 is 4. Square root of 4 is 2. 2 plus 5 is 7. Okay, if I put in 7, nope. 8, nope. 9, 10, 11. So 11 minus 2 is 9. The square root of 9 is 3. 3 plus 5 is 8. Okay, so we go 2, 5. Now this graph, 1, 2, 3, 4, 5, is not the best. It keeps getting distorted as more copies have been made. So you can use a ruler and make some harsher lines, but normally your graphs are going to look like this. 3, 6. So go to 3. I'm going to go 1 to 6. Go to 6, 7. 3, 4, 5, 6. And go up to 7. And 11. 10, 11. And go up to 8. So it's going to be this curve. Now, people want to tend to connect this. No, you don't have any values that exist here. If you actually try the number 1, if I plug in 1, 1 minus 2 is -1. You can't take the square root of -1. It's not going to work. Okay. All right. So same thing here. You start by looking at the radicand. X plus 3 has to be greater than or equal to 0. So you have to start with -3. You start with -3, you get 0. Minus 1 is -1. Okay. Let's try -2. That will work. -2 plus 3, okay, is 1. I want you to keep trying on your own and then come back and check. Square root of 1 is 1. -2 minus 3 is -3. Try -1. No. 0. No. 1. Square root of 4 is 2. Now, I'm doing a lot in my head. If you don't want to do a lot in your head, use your calculator to type in the numbers. Or off to the side, write it. I put in 1, I get 4. Square root of 4 is 2. -4 minus 3. Or minus 1 is -5. I put in 2. No. 3. No. 4. 5. 6. 6 plus 3 is 9. Square root of 9 is 3. 3 times -2 is -6, -7. Okay. That's good. Let's try it. 3, -1. -2, -3. 1, -5. 6, -7. Does it have that curve? Yeah, but it's backwards. Should it be backwards? Well, yeah. This negative means it reflected on the x-axis. 2 means a vertical stretch of 2. It went down 1, and it went to the left 3. So did it? Went to the left 3. Yep, it reflected and it stretched, and it went down 1. So use your transformations to see if your graph is accurate. Here, graph the square root inequality. All right. So x minus 4 has to be greater than or equal to 0. Okay, so we're going to start with 4. So let's make an xy table, t table. If I put 4 in, I'm going to get 0. 0 minus 6 is -6. I have to be greater than or equal to 4. So if I put in 5, that will work as well. If I put in 6, no. 7, 8, yeah, let's do it. 4 square root of 4 is 2. 2 minus 6 is -4. 9, 10, 11, 12, 13. Get 9. Square root of 9 is 3. 3 minus 6 is -3. Let's try that. So let's go to 4, -6. 5, -5. 8, -4. 13, -3. Now, wait, I can't make a solid line because this is an inequality. And because there's no equal, it's just less than, it's a dotted line. And I'm going to shade below. Now, some kids kind of get nervous and they just kind of stop here. Well, it's going to keep continuing on and on and on. But how far left do you go? Well, you can't go below this line. So it's got to be up to here. Okay, so you have to ask yourself, is it solid or dotted? Where do you shade, above or below? Well, it's less than, and your y values are less than here. Okay, just make sure you don't go past your domain. If you shade over here, it's wrong. Okay, All right, that's it for 6-3. There is not a good assessment for this in Delta Math. So what I'd like you to do is the homework quiz in the classwork section. And I want you to create it as a PDF and send it to me. A good app is Cam Scanner. And if you're stuck and you're struggling and you don't know how, you can just send it as a picture as well. You can do this via email. Okay.